This short video is to explain how to get Jellyfin's hardware transcoding working on the DietPi operating system for your Radxa Rock 5A, 5B, 5B+, and 5C. It may also work on other RK3588 single-board computers such as the Orange Pi 5. Although this has not been tested. A quick explanation on transcoding is in order. Transcoding is basically converting a video file from one format into another on the fly, so it plays properly on whatever device you're watching it on. For example, say you've got a 4K movie file encoded in something modern like HEVC, but you're trying to watch it on an old Roku box that could only handle H.264 video. Or if you're watching your movie remotely, the bitrate could be too high for your internet connection. Then the file needs to be converted in real time into a format that your device can actually decode, at a bitrate your connection can keep up with. Ideally, you would want your Rock 5 to use its hardware transcoding abilities over software transcoding, as it's much faster. That's because software transcoding relies purely on the CPU grinding through the conversion frame by frame, whereas hardware transcoding offloads the job to a dedicated chip built specifically for that task. For example, a typical movie runs at 24 frames per second. The Rock 5 would have difficulty meeting that 24 frames per second if it was software transcoding a 4K HEVC movie on the fly. The result would be stuttered playback, if anything at all. It might handle 1080p video at a push, but the 8 cores of the Rock 5 would be hammered with rising CPU temps. With a lightweight OS that's ideal for the Rock 5, DietPi does most of the work for you. However, there are a few things that need doing before you can fully enjoy hardware transcoding. You can install Jellyfin via the DietPi-software command. We won't go into detail about setting up Jellyfin, we'll just focus on hardware transcoding for this video. Select Browse Software. Select Jellyfin, FOSS Web Interface Media Streaming Server. Press space to select. Press Tab to highlight Confirm and press Return. Highlight Install, press the Tab key to highlight Select. Press Return and return again. Installation should take a little over a minute. Once installed, you can check if the Jellyfin service is working by typing systemctl space status space Jellyfin, all lowercase. You should see that it's active. Now check the local IP address that your Radxa Rock 5 is using by typing IP space A. Press Return. And remember, all lowercase. For me, my internal IP address was 192.168.1.204. Jellyfin usually defaults to port 8096, but on DietPi OS it's 8097. Now, on a device with a web browser, in my case it'll be my trusty AMD Ryzen Windows 11 PC, type in the Rock 5's IP address, for example, 192.168.1.204, 8097 and press Return. You should then be guided towards setting up Jellyfin. In my case, this is already done. But it should be pretty easy. Once done, log in with your new username and password. Jellyfin defaults to software transcoding. Let's force transcoding by lowering the bitrate by clicking the cog at the bottom right and selecting a lower quality. For 20 kps for example. As you can see, the ROK 5 still has enough CPU grunt to play the movie. You can see the amount of frames per second being transcoded by opening a second browser window and selecting Dashboard. 86 frames per second is pretty decent, more than enough to keep up with the movie. However, a 4K movie with a 10-bit color depth would hit that CPU a lot harder. And that problem would be even more compounded if multiple users were using your Jellyfin server at the same time. Besides, you paid for hardware transcoding, you're going to get hardware transcoding. Let's fix this. Back to your ROK 5. There are just 3 commands and a Jellyfin server restart needed to enable hardware transcoding. On the ROK 5, type in chmod space 777 space /dev/dri/render d128 and press return. Type chmod space 777 space /dev//RKMPP_service, press return. Type chmod space 777 space /dev/RGA, press return. Now restart the Jellyfin service by typing systemctl space restart space Jellyfin and return. Now back on your Jellyfin user interface on your PC or media device. Click Dashboard on the menu on the left. Playback. Transcoding. For hardware acceleration, select RKMPP. Enable hardware decoding for H.264, HEVC, MPEG-2, MPEG-4, VP8, VP9, AV1, HEVC 10-bit, VP9 10-bit. Tick Enable hardware encoding. Then save. Now let's test the same movie. As you can see, the movie is being transcoded at around 1200 frames per second. At this rate, a full movie can be transcoded within 2 or 3 minutes. This leaves more than enough room for 4K 10-bit video and multiple streams at the same time. Well done, job's done. However, if you want to make the settings survive a system reboot, do the following. Back onto your ROK 5, type the following. nano/usr/local/bin/jellyfin-rockchip-fix.sh. Type in the following that is displayed. Pause the video if you need more time. Now press Ctrl O, press Y, press return, and Ctrl X to exit. Type chmod space +x space /usr/local/bin/jellyfin-rockchip-fix.sh. Now for the last bit, let's create a systemd services by typing nano space /etc/system/systems/jellyfin-rockchip-fix.service. Type in the following that is displayed. Pause the video if you need more time. Now press Ctrl O, press Y, press return, and Ctrl X to exit. To enable the service, type System Control space daemon-reload, press return. Type System Control space enable space Jellyfin-rockchip-fix.service. All done. Type reboot to make sure it sticks.